Today, in 11.2, we're going to be talking about the quadratic formula. There's a chance that you learned the quadratic formula in Algebra 1, but if you did, there's still something that we're going to do that's new today. We're going to talk about where the quadratic formula comes from, and this is one of the main differences between Algebra 1 and Algebra 2. In Algebra 2, we spend a lot more time talking about where things came from and why things are the way they are. So, what we're going to do is we're going to create the quadratic formula. This is also going to work as an example of how formulas in general get created. They typically are created by starting with a very general thing like this, where normally we would have numbers for a, b, and c, but we're kind of leaving them unspecified right now. You go through the steps that you already know, which may be complicated, and then when you get to the end, you never have to go through those steps again. You just plug in for the a, b, and c at the end and skip all the intervening work. So currently, the technique that we have for solving something like this is completing the square. But once we've worked completing the square on this, we'll have a new formula that we can use instead. So right now, we're going to solve this thing by using completing the square. So, let's think about the steps. The first step for completing the square is to take the c part and move it to the other side. So we have ax squared plus bx equals negative c. The other thing that we typically have to do is take the leading coefficient, in this case an a, but remember that stands for some number, and divide everything by it. And that's where the fact that we've got letters here starts to become challenging. But it's not quite as challenging as you might think from looking at it. Yes, we have a fraction there, b divided by a, but we worked with numerical fractions in 11.1. This isn't the first time we've seen fractions show up when we're using completing the square. So we just sort of groan a little bit. We're not happy about that, but we go forward anyways. Let's see, what's the next step? Well, this is the step where we go sort of forwards and then backwards, where we're trying to figure out something to put here, which will lead us to something that we have to add to both sides. And that's going to be the key. Here in a second, we're going to add something on both sides of the equation. So, what are we going to add to both sides of the equation? Well, let's see. Take this here, cut it in half, and we've got to make sure we do this right. b divided by a cut in half. It's probably easier to say b divided by a times 1/2, because then it's a lot easier to see that you get b over 2a. And then you take that and you square it. Oh, man, that's going to be a mess, isn't it? We know it's going to be a mess, so take your time, think it through carefully. When you square that, you're going to have b squared in the numerator, and you're going to have 4a squared in the denominator. So that's the thing we have to add on both sides, b squared over 4a squared. So that's how you figure out what to add on both sides in general, and it's about as bad as it could ever be in this case. The other thing we have to do is on that right-hand side where we had negative c over a and we added b squared over 4a squared, we got to build ourselves a common denominator there. So it looks like my common denominator is going to be 4a squared. So this fraction here, we're going to have to multiply top and bottom by 4a. So let's make sure we do this work right. I've got 4ac over 4a squared plus b squared over 4a squared. And if we're trying to put those two together, it's probably easier to put this positive one first and the negative one second. So we're going to write that as b squared minus 4ac all over 4a squared. Make the fraction as legible as possible since we've got plenty of ugly things in this problem already. Then we take a square root. And this part, although it's not pretty, it is easy. The square root on this side is just going to cancel out that squared. Don't forget you plus or minus. And when we do the square roots here, the square root of the numerator is not going to simplify any. It's just going to be a mess. Let me careful and write it right. B squared minus 4ac inside the root. But the square root of the denominator, that simplifies a lot. Square root of 4 is 2, square root of a squared is a. So we get plus or minus this. And at this point, we're almost done. I mean, we've almost finished solving this thing. We just have to move that b over 2a thing to the other side of the equation and get this. Well, this still can be cleaned up a bit. If you're looking at that and not liking what you're seeing, I totally understand, because it's two fractions, but those two fractions, they've got the same denominator. So why don't we make that a little nicer? And that's exactly what we do. We make a single fraction out of that because they have the same denominator. It's going to be one big fraction where 2a is the denominator, and the numerator is negative b plus or minus square root b squared minus 4ac. And if you've seen the quadratic formula before, you recognize that. That is the quadratic formula. The whole point of doing something like this, well, I guess there's 2 points. One of the 2 points here is to learn these things aren't magic. These don't just appear out of nowhere. There's a reason why that's the formula. And it's the formula because that's what you get if you solve it the other way. The other point is, from now on, in the future, if you're solving something quadratic, you can skip right from there to there. You don't have to do all those steps in between anymore because you can just cut to the end. It's like reading the last page of a mystery novel. Oh, the butler did it. You just go right to the end and plug in for A, B, and C when you're finished. Now, there are 2 things about that that are tricky. One of them is kind of obvious, and that is you're going to have to memorize this if you want to use it. If you don't want to memorize it, the other option is use completing the square, and some people prefer completing the square. It's usually about 10% to 20% of students prefer completing the square, but some people actually would rather do completing the square than memorizing this messy, ugly thing here. But if you like this, like 80 to 90% of people do, the price you have to pay is you have to memorize the formula. And then the other thing that's a little tricky here is that there are some things that can happen that make the process of just plugging in for A, B, and C not quite as easy as it might look. So we're going to take a look at 2 or 3 examples that will help illustrate the slightly complicated cases so that you can handle what happens in those circumstances. Okay, so one of the things that you should be aware of is we don't always use the letter x. Don't let that throw you. Even though the formula there says x equals da-da-da-da-da, you could have any letter of the alphabet. So if it helps, if you're one of those people who prefers to use the letter x, it's acceptable to rewrite the equation using the letter x instead, just to make you happier and more comfortable. Just make sure when you're done you change back. Don't write x equals something for your answer, because that wasn't really the equation. So that is an acceptable little trick that you can pull. Then, plug it into the formula. Have you memorized it yet? If not, pause the video, or scroll back into the video and see what it was a second ago, and try to memorize it starting now. If you say, I'll get to that later, you're never going to get to it. Try memorizing it right now. It's not on the screen. See if you can write it down on a piece of paper without looking it up. And if not, keep practicing until you can. So, plugging into that quadratic formula, we're going to have negative b. And remember, if you don't see a coefficient, the coefficient is 1, so b is 1 here. So negative 1 plus or minus, and the big messy square root, b squared, well, 1 squared will be 1, minus 4 times a, which is 1, times c, which is 4, divided by 2 times a. Well, a is 1, so 2 times a is 2. And as you start to do the arithmetic that is sort of the last step of the quadratic formula, you realize that the inside of this root comes out negative. That's 1 minus 16. Negative 15 in there. Which means, yes, you get complex numbers here. Remember, a square root of a negative is not the end of a problem anymore. That used to be the way it was before you learned about complex numbers. But nowadays, whenever you get a square root of a negative, that just means you get I. So that would be your answer, except not really, for 2 different reasons. One reason is that's the wrong letter. This equation was not about x. this equation was about a. So the answer isn't x equals anything at all. It's a equals something or other. But then the other thing is, this is a complex number. It's got I in it. And anytime you're talking about a complex answer to something, there is a standard form that you have to write complex numbers in. You have to break this up into two fractions, where there's one fraction that does not have I, and then a second fraction that is related to I. So, the message to get out of this example, the lesson to learn here is, you can change variables if it makes you feel more comfortable, but make sure you change back. And the other message is, square roots and negatives give you complex numbers, which is not the same as no solution. You have to have an answer and put it in complex number form. So that's one thing. Here's the next example. This is going to illustrate a different idea. And again, have you got the formula memorized yet? If not, pause, see if you can remember what it is, write it down on paper, see if you get it right. Okay, so negative b, well, b is negative 51. Watch out for double negatives. Negative 51 is just plain 51. Plus or minus, big old square root, b squared. Oh my gosh. 51 squared? This is where you probably want to grab a calculator. I don't know what 51 squared is, but I press buttons and I discover that 51 squared is 2,601. Minus 4 times a times c, and yeah, I'm going to be doing that stuff on a calculator here in a second. There's no way I'm going to be able to figure that out in my head. All over 2a. So okay, continuing with the calculator, 2601 minus 4 times 2 times 72 equals 2025. So 51 plus or minus the square root of 2025 over 4. And then you got to simplify that root. I mean, it should be obvious that at least 25 goes into 2025. So it should be pretty quickly realized that that's going to simplify. But it actually simplifies more than you might imagine. 25 goes into that for sure. But what's it 25 times? Well, it's 25 times 81, which is also a perfect square. So really, this can be simplified a lot more than you think. Square root of 2025 is 45. Not 45 square root of something, just plain 45. So here's an interesting case that you might not know you could run into. What are you supposed to do if the root entirely simplifies away like this? Well, what you're expected to do is actually work out the arithmetic of the plus and the minus here, because this is definitely not simplest form. 51 plus 45 over 2 can obviously be simplified, and 51 minus 45 over 2, same issue, obviously simplifiable. So if those had been roots, you couldn't have simplified them, but here you can. So what we have here is 96 over 2. Oh, wait a sec. 96 over 2. I'll definitely simplify that more. And then 51 minus 45 is 6 over 2. Oh, yeah, I'm definitely going to simplify that more as well. So, wait a sec. What did I do to my denominator? I just realized I had the wrong denominator here. It was 4 and then just magically changed to 2, huh? No, it should still be 4. My apologies. If you were confused a second ago, so was I, apparently. But both of those fractions should certainly be reduced. 96 over 4, that reduces to 24, and 6 over 4 reduces to 3 over 2. So if you have no roots in your answer at all, you're expected to continue the arithmetic all the way down to what those numbers actually are. When you look at those answers, you see they're definitely simpler than what we had a second ago. The other thing that's kind of funny here is when you get an answer like this, what this is telling you is you could have factored this polynomial. And this is actually something that back in Algebra 1, just about every student wishes they had. They wish they had some way to know whether a polynomial factored. Is it prime? Can I factor it? Students want to know if there's a way to figure that out. And there is a way to figure that out, but you don't like it. The way to figure it out is use the quadratic formula, and if the square root simplifies entirely away, then you can factor the thing instead. So it's kind of not worth it, but there is a technique. It's not impossible, it's just not worth it. All right, one last example to illustrate a key idea. This one here. This is kind of a funny one. At first, everything seems to be going normally. You got your quadratic formula, so you go x equals negative b. We got a double negative, so 20 plus or minus square root of 20 squared is 400 minus 4 times a times c all over 2a. But the thing that's kind of funny in this problem is what happens once you simplify down the inside of that root. 400 minus all of that stuff is 0. So this is also something that can happen that you might not have been aware, but once you see it, it's like, oh, duh, yeah, of course that could happen. You could get a square root of 0 in there. It's got to be rare. I mean, these two numbers here have to balance out perfectly, but it can happen. So what that means is you aren't really getting two answers. You're getting 20 plus 0 over 50 and 20 minus 0 over 50, and those are both 20 over 50. So it would be silly to say that your two answers are 20 over 50 and 20 over 50. That's just kind of redundant. Why are you saying it twice? So don't say it twice. That's kind of silly. And of course reduce it. I mean, this is a regular everyday fraction. 20 over 50, come on, that's 2 over 5. Of course you're expected to reduce that. So the lesson here in this one is, if things balance out exactly right, and you've got a square root of 0 there, it is possible to have only one answer to a quadratic equation. But almost always you get two answers. The plus or minus normally produces two different answers, but it's possible, but rare, to get one.